Have you ever paused to consider that nearly every modern human experience, from the heartbeat of your smartphone to the vast simulations predicting the path of a hurricane, relies on a tiny sliver of etched sand? We live in an era where we take speed for granted. Yet we rarely look under the hood to see the mechanical ballet occurring billions of times per second. If your computer were a kitchen, the cores are the chefs. But how many chefs do you actually need? Is a single master chef better than 100 line cooks? Today, we are going on a journey through the evolution of the silicon brain, tracing the path from the lonely, overheating pioneers of the past to the monstrous multi-core titans that power our digital civilization. In the beginning, there was the one. To understand where we are, we must look back at the late 1990s and early 2000s. This was the era of the megahertz myth. Computing was a linear affair. A single core was the undisputed brain of the operation, a solitary worker tasked with every single calculation the machine required. Think of the Pentium 4? For years, the industry's philosophy was simple. If you want more power, you just make the core run faster. We pushed clock speeds higher and higher, chasing the 4 gigahertz dream, but we hit a physical wall, the thermal limit. As we pumped more electricity into that single core to make it vibrate faster, it generated heat that could literally melt the chip. The single core was efficient in its simplicity, but it was lonely. It could only do one thing at a time. If your antivirus started a scan while you were writing an email, your computer would stutter and gasp. Yet, the single core never truly died. Today, it lives on as the humble hero of embedded systems. It's in your microwave, your digital watch, and the controller of your coffee maker. It represents the minimalist brain, the beginning of our journey, where performance was measured by how fast one person could work before they burst into flames. As the heat limits of the single-core era became insurmountable, engineers realized they couldn't make the worker faster, so they hired a second one. This was the birth of the dual-core era, the survival baseline for what we consider a modern computing experience. In a dual-core system, the operating system finally gained the ability to breathe. Imagine a kitchen where one chef handles the stove while the other preps the ingredients. Suddenly, the stutter began to fade. One core could manage the background clutter of Windows or Mac OS, while the other dedicated its energy to your browser or Word document. Today, 2 cores represent the functional minimum. If you go lower, the system feels clogged. A dual-core CPU is the reliable sedan of the computing world. It's not going to win a race, and it will struggle if you ask it to do 3 things at once. But for a basic office setup or a student's Chromebook, it provides the essential stability required to navigate the 21st century. It is the moment computing moved from waiting to working. By the mid-2010s, the quad-core became the gold standard, and today, it remains the true entry point for anyone who wants a real PC experience. 4 cores represent a psychological and technical threshold. It is the point where a computer stops feeling like a tool and starts feeling like an extension of your thoughts. With 4 cores, the workload is distributed with enough redundancy that a sudden spike in background activity like a Windows update or a heavy web ad doesn't paralyze your system. This is where gaming truly began to flourish. For years, game developers optimized for 4 threads, allowing one core to handle AI, one for physics, one for rendering, and one for the OS. However, we are starting to see the limits of 4 cores. In a world of 4,000 streaming, Discord calls, and high refresh rate gaming, a 4-core chip can start to show strain. It is the threshold of capability. It is enough to get the job done, but you can hear the fans spinning faster as it works to keep up with our increasingly demanding digital lives. If 4 cores are about capability, 6 cores are about effortlessness. This is the tier where the friction of computing simply disappears for 90% of the population. When the industry shifted towards 6-core processors, like the legendary Ryzen 5 or the modern i5 series, the mid-range became the new high-end. 6 cores provide a unique balance. You have enough single-core speed to ensure that apps open instantly, but you also have enough parallel capacity to multitask without fear. You can have 30 Chrome tabs open, a Zoom call running, and a spreadsheet calculating in the background, and the mouse cursor will still glide across the screen with buttery smoothness. This is the Goldilocks zone. It's not a premium luxury. It's a smart investment. It offers near-flagship responsiveness without the flagship price tag. For the average user, 6 cores represent the moment where you stop thinking about your CPU and start focusing on your work. Now we enter the realm of the enthusiasts. 8 cores are currently the gaming equilibrium. Why 8? Because the world of gaming is dictated by consoles. Both the PlayStation 5 and the Xbox Series X utilize 8-core architectures. Consequently, game engines are built to split their tasks across 8 primary lanes. But in this tier, raw core count isn't the only story. This is where we see the magic of cache architecture. Chips like the Ryzen 7 800X3D have proven that sometimes having more cores is less important than having closer memory. By stacking 3 DV cache directly on the CPU, we reduce the time it takes for those 8 cores to talk to the memory. In the 8-core world, it's not just about how many chefs are in the kitchen. It's about how close the refrigerator is to the stove. This tier is optimized for consistency. It's for the gamer who demands 0 stutters and the highest possible frames per second. It is the perfect marriage of power and efficiency. When we jump to 16 cores, we leave the consumer world and enter the prosumer landscape. These are uniform high-performance designs, 16 identical powerful cores built for the heavy lifters. If you are a software developer compiling massive libraries of code, or a creative professional rendering 4K video, 16 cores are your best friend. This architecture is designed for sustained throughput. It doesn't just burst with speed. It holds that speed for hours. These chips excel at virtualization, running multiple virtual computers inside one physical box. It's a powerhouse design that doesn't care about efficiency cores. It cares about raw, unadulterated muscle. When you have 32 threads at your disposal, the machine stops being a device and starts being a workstation. The journey takes a fascinating turn at 24 cores. This is the era of asymmetric architecture. Borrowing a page from smartphone design, companies like Intel began mixing performance cores, P-cores, with efficiency cores, E-cores. Imagine a 24-core CPU as a specialized team. You have 8 Olympic sprinters, P-cores, for your heavy gaming or editing, and 16 marathon runners, E-cores, to handle the background noise of the internet, system updates, and music players. The secret sauce here isn't just the cores. It's the scheduler. The scheduler is the brain of the brain, the traffic cop that decides which task goes to which core. When it works perfectly, your PC feels more responsive than ever before because the big cores are always free and ready to jump into action, while the little cores keep the lights on. This is the cutting edge of real-world efficiency. We now move into the stratosphere of computing. 64 cores. This is the territory of the AMD Threadripper and the highest-end workstations. At this level, we aren't just doing tasks. We are simulating reality. These CPUs are for the Hollywood animators, the data scientists, and the engineers designing the next generation of jet engines. With 64 cores, you have a massive parallel highway. You can render a complex 3D scene in the background while still having enough power left over to play a high-end game or edit another project in the foreground. The beauty of a 64-core workstation is that it empowers the creator to stay in the flow. You no longer have to take a coffee break every time you hit render. The machine is so powerful that it remains interactive even under loads that would make a standard desktop explode. Finally, we reach the summit, 96 cores and beyond. These are the titans of the data center, the AMD EPYC and Intel Xeon scalable processors. Here the rules change entirely. Single task speed is no longer the priority. Total throughput is king. These processors do not live in homes. They live in climate-controlled racks, powering the cloud. When you watch a video, save a file to the web, or ask an AI a question, a 96-core beast is likely orchestrating that data. They are designed to handle thousands of simultaneous users. They are the digital infrastructure of our world. A 96-core CPU is an orchestra of massive proportions, conducting millions of tiny conversations at once. It is the final evolution of the silicon brain, a machine so complex that it moves beyond personal computing and into the realm of planetary-scale intelligence. Looking back at this progression, we see a clear narrative. Computing has moved from speed to efficiency and finally to specialization. We no longer ask, how fast is it? But rather, how many things can it do at once and how well does it prioritize them? The history of the CPU core is a mirror of human ambition. We started with one worker, pushed them to their limit, and when they could do no more, we learned the power of collaboration. We learned that a team of specialized workers, some fast, some efficient, some numerous, is always better than a single, exhausted genius. If you enjoyed this deep dive into the heart of the machine, please subscribe to the channel and hit that notification bell. We have many more stories to tell about the invisible world that shapes our reality.